different ways. If y'all have questions, like we can just start with those things. I prefer just to keep it on chapter 1. We're done with chapter 1. So the big topics were unit conversions, dimensional analysis, estimates and orders of magnitude, and trigonometry with coordinate systems. I think that most of you have seen that elsewhere, but it's always good to see it a little bit more because, you know, on this first chapter especially, I want to get those things perfectly right because we're going to sort of build on those things as we go along in the course. Okay? Or I can just go through the exams and we can sort of look at some questions from the exams that you have in your book. I don't think we've done any in class from those, have we? That might be a better route just so that you get a little practice because you might not really know what you're struggling with just now, or it might be everything. Or if there are particular questions from that old exam, we can look at them in particular. So what I'm going to do right now is I'll just go to the fall 15 exam. That's what y'all have, is that right? And we'll just take a look and see what are some of these that we want to look at. So look, I'm just going to sort of scroll through, and then y'all holler out if, oh, number 4, number 6, or whatever, okay? There's trig, unit conversions. After 10, we get into our kinematic stuff. What else? What do we want to look at? Which of these?
Start with number 1.
We can start with number 1. So a mid-sized car has an approximate volume of what? And so, you know, we're really looking for an order of magnitudes. You want to think about, if I have a car, first of all, treat it as a rectangular prism, and that'll give us a good first order approximation of its volume. And oh goodness, how long is a car? 10 feet, 12 feet, that's about 3 meters, 4 meters or so. So we'll say that this side is about 3 meters. How wide is the car? Well, no, it's not as, oh, 5, 6 feet. A meter, 2 meters probably, about 6 feet across. I'm sorry, y'all are talking in British system. I don't understand British. All right, and then what is the height of a car? Well, it comes out about here, right? 1.5 meters. We'll just call it 2 meters, and then we'll see where we go from there. So that's 3 times 2 is 6, times 2 is 12. So what is the approximate volume of a car? Not a trick question. What do y'all think? Is it 15, 150, 1,500? It's going to be 15, right? It's not 150. Like, there is no car, a reasonable car, that's 150 cubic meters. That would be a car that's 10 times the volume of your normal car. Okay? So your approximations will be similar to that. What about number 2? This is another approximation. A guy in a kayak can travel approximately what distance in 10 minutes? Well, many of y'all have been in kayaks, right? In a second, how far do you go in a kayak? Just at a normal pace. 2 meters, maybe 2 meters a second. So let's just go with that. That seems reasonable. 2 meters a second. So if I go 2 meters per second, listen, we're going to get into kinematics, but this is really just sort of looking at the dimensional analysis. If I have this and I want it to become a distance, then I know that I need to multiply it times what quantity to make the units meters. I need to multiply it times a time, right, to get rid of those seconds and make it a distance. So if I multiply this times 10 minutes, then the time in the numerator will cancel out with the time in the denominator. The equation that I'm looking at here is V is equal to X divided by T, or I'm looking for X, which is going to be V times T. We're going to see those equations on Monday when we start to do kinematics, and we'll see some that are more complicated. And actually, this comes up on your homework. So if you just, several of your kinematics problems in your homework, just go with this very basic definition of position, speed, and time. So anyway, here, my units don't match up, so I need to do a unit conversion. In 1 minute, there are 60 seconds. So in 10 minutes, there are how many seconds? There are 600 seconds, so that's 600 seconds. So I've got 2 times 600. That's 1,200 meters. Oh, 1,200 meters. So looks like I was thinking, well, you don't go 2 meters per second, but you go more like 1 meter per second. So that's the one that's closer. If I were to go to 6,000, that's 5 times. So that's really going 10 meters a second. It might be possible on a kayak, but that's booking it, going 10 meters a second. That's a good current, right? That's going from like here, what? About halfway to the back, or like back on the carpeted area in 1 second. It was booking, right? So, yeah, the right answer here would be 600. It could be a little bit more, but it's certainly not going to be as much as 6,000. So these approximations, they're those types of things where you need to have a common sense view of the metric system and how it's applied to real life scenarios. Okay? Students often have difficulty. Like I think that those words are probably entering your mind and you're saying, well, that's simple. But then when you get to the test and it's something different, then students sort of freak out and they're like, oh, I don't know what that is. John?
Could it possibly be in 6,000 if you were thinking like kayak on the mountain rapids?
Well, yeah, I guess so.
Well, like
yeah.
that's what I was.
That's what you were thinking?
Yeah, I was
well, we
thinking.
don't get rapids around here. Where are you going to get rapids?
Where
about?
We got a little waterfall.
Oh, on the Weir here in Thibodeau? All right. Yeah, 6,000. Okay. You want to do some of these dimensional analysis stuff? This is another thing that people find difficult. So, yeah, John.
For how we have capital P for into the third, and then we have lowercase d's in divided by seconds, meters divided by seconds.
Yes. So what he's talking about. Well, this is little v. Usually I'll do it as a script v. So little v is velocity. And capital V, we're actually not going to use that much until we get into fluids when we're talking about volumes. This is volume. So let's see, usually it's going to be the lowercase v in this first chapter, but you could see volumes as well. One's uppercase, one's lowercase. Big V is volume, little v is velocity or speed.
It was just one to tell.
I understand. And on the test, if you see something and you're not sure, just call me over. I will tell you that. If you have questions, I'll answer them, as long as they're questions that I can answer. I'm not going to tell you if you're right or what to do next, but if you're just asking for a clarification, then I will answer that. And if it's something the whole class needs to know, then I'll tell them too. Okay? But if it's something like that, is this a capital or a lowercase v? I will absolutely answer that question. That's my job. They pay me bukus of money to answer your question. Well, they don't pay me that much, but they pay me enough, and I like it. Okay? All right, let's do these dimensional analysis. Remember with these, let me just make a point here. Just to be clear, I'll send y'all an email. But, and this is for folks that are watching the video. But, like y'all are taking notes. Those notes should not come back to me. You understand what I'm saying? Like, don't give them to your brother. I know that you wouldn't do that. But, like, it's not cool if y'all take your notes and just give them to somebody so that they can get credit for the extra credit session. And I tend to find out about these things. And if I find out about them, which I tend to do, I will not be happy. And you won't get credit, and they won't get credit, like, probably not at all. So just hang on to your notes. Don't give them to anybody. Okay? You understand, everybody? Okay. Y'all understand, people in the internet world? All right. Okay, so v squared is v naught squared plus 2ax. What I would do, first of all, I know that these units are going to match because those are exactly the same. The naught just means initial. So v is meter per second, but it's squared, so meters per second squared, equals meters squared per second squared. Like I said, that's the same. The 2 I don't even worry about. That's acceleration is meters per second squared, and x is meters. So this one is really the only one I need to simplify, and it becomes meters squared per second squared, which checks out here, here, and here. So this one is dimensionally correct. Follow? Let's try the next one. Actually, let's try the third one. Is the third one dimensionally correct? It's fairly simple. Is it dimensionally correct? Right. V is meters per second. X is meters. T is seconds. So that one's okay. So look, I can get rid of answers now. And this is a good practice on any multiple choice test. The MCAT, is the Praxis multiple choice? I think there must any sec eds?
Yeah, I think it has a writing portion, but it also has a multiple choice.
Okay, so if you're doing multiple choice tests, this is a good practice to go through and say, which ones can I get rid of? Well, I know I can get rid of this one, I can get rid of this one, and this one. So I know it needs to be either A or E. Okay? That's a great practice. And often on my tests, you don't even have to finish a problem. You just think about what answers are not even reasonable and get rid of those answers, and then you're left with 2, maybe even 1 answer. It's a great practice for multiple choice tests. But also know that on my test, let's be very careful because I know the mistakes that you will make. And I make those same mistakes and calculate the answer from those mistakes, and that's usually going to be one of the options. So that means that if you get an answer and you're all confident about it, it could be wrong because you made a mistake. That's a common mistake. Just because you get an answer doesn't mean it's right. Okay? I know that's not tricky. I'm not going to use that word. Like, that's a good test that tests your knowledge. But just make sure that you're practice. That's how you do well in this class, is that you practice a lot. And that way when you get to the exam, it's going to be like second nature for you. You're not even really going to have to think about it. You're going to go in and just boom, 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 and you'll be done. Okay? I don't want to scare you, but I want you to be prepared too. Okay, so let's look at this one. This one's more complicated. First of all, I notice that I can get rid of all the m's there because I can divide the entire equation through by m. I can also just forget about that half because it doesn't have any units. And so now I have v squared, that's meters per second, but it's squared, so meters squared per second squared, plus x, which is meters per second squared. So far I'm okay. Meters squared per second squared so far. And then I have meters squared, goodness bless you, divided by t, which is seconds. Is that equation dimensionally correct? No. No, because look, I have seconds here, but seconds squared here. It's very similar. It's almost right. I just needed an extra little t. So that one is not correct. So the answer is A, 1 and 3. All right? Yeah. Tell me your name again.
Courtney.
Okay, Courtney.
Is there 28 questions on every exam? Or like?
That's usually the case. I found that sort of a sweet spot. That it's not too long, although you're going to be in there almost the entire time. Not everybody, like most students will be there the whole time. To do 28 questions in 55 minutes, or I give y'all an hour actually, a little extra. That's 2 minutes per question. I mean, y'all done that practice questions in class. It can take 2 minutes to read a question. You gotta be fast. Alright? The part of my test is just being practice with doing multiple choice exams, knowing the little tricks to select answers, but that's a good skill to learn for other classes and just your future, entrance exams and the various things that you guys will take. Okay. We have another one? Yeah, look, this test had 3 questions on dimensional analysis. And you know what? I have a spreadsheet, and it tells me how many questions I want on all these various topics. And so that doesn't usually vary. So chances are that on your test, you're also going to have 3 questions on dimensional analysis. I don't usually vary that. I might, but you're going to have between 2 and 4 questions, probably 3. Okay, so let's look at this one. If I want to know what B is, well, gosh, how would we go about this? We did a question like this in class today, I think, hard Wednesday. If I wanted to find the units for B, how would I go about that? There are two steps that you would do. The first step would be what? What would be my very first step? Thank you, Lorenzo. I can eliminate what from this? The m's, the masses, right? They go away. Be careful, too, that you distinguish your variables and your units, because m is in units of kilograms, but x is in units of meters. So just be careful with that. So let's get rid of our m's. I can just divide through. And then what's the other thing I can get rid of? Oh, you're right. Look at y'all. That's not what I intended. But yes, you're right. And then what else can you get rid of? The 3 and the pi. Pi is just a number, right? It's 3.14. So that's a constant. I can get rid of that. So now I have 1 over t equals b divided by a. And then I want to know the units for b. So I'm just going to solve this whole thing for b. I would multiply both sides by a, or cross multiply, however you want to think about this. And so I get b is equal to a divided by t. And then I would put in my units. Meters per second squared, 1 over seconds. So my units are going to be meters per second cubed. All right? Look, I could have, again, be careful with your m's and your, as a variable and as a unit. Students are sometimes confused by that. Just be careful. But you likely will see m as a variable and m as a unit. So make sure that in your mind you're very clear of, okay, I'm no longer dealing with variables, now I'm dealing with units. Clear with me on that, y'all? Yes, okay. You want to do some more of those? I have lots more. We can go to other exams. You just won't have them in your book. Yeah? All right. Oh, wait. Do y'all have this one? Didn't I just do this? Oh, yeah. Okay. So this one is very similar. Actually, number 2 here about the kayak was in that exam, too. I don't usually repeat questions. What was that I was just in? It's exam 1. Oh, I know what it is. I had 2 different exams for fall 15. Like, I had one class, but I had 2 different exams, like 2 versions. So that's why some of the questions are the same. Yes, y'all might have this one. Do y'all have this one? With the head? Yeah, the last one. Well, let's look at this one. What is the volume of a person's head? Have you ever thought about that? You did think of? No, we did the mass of their head, right? And we decided that some of y'all have large heads. No, you have very light heads. That's what it was. Yeah, I know, yes, debatable. Yes, you're right. Trying to forget about it. What's the volume of somebody's head? What is the height of somebody's head? Well, this is about what? 20 centimeters, maybe? Let's just treat it as a block, like a, what's that game? Mine, whatever. What is that game? Minesweeper? Not Minesweeper. Minecraft, yes. So if we do 20 centimeters by maybe, I don't know, 15 centimeters by 15, that's 30. What is that? I should do some better numbers. I'm going to do whole numbers, 10 and 20 here. So that's 40, 400 times 10 is 4,000. So I get thousands of square centimeters. So the answer here is going to be D. You follow what I'm saying there? It's an estimation, and you just sort of estimate, and then you're going to pick the most reasonable number that's close. All right?
Wait, so you said you got 1,000?
I got, well, with those numbers, 20 times 20 times 10, 20 times 20 is 400, right? 40, 400, 4,000, which is a lot bigger than 800. So I think my numbers are a little small. A 10 centimeter head is like this wide. That's a little small. But it's an estimate. You know, trying to get close enough so that you can rule out the other answers. Okay? That's true with all the estimates. All right, how would we find the units for B here? Be careful here, because before we could cancel out things, but we cannot cancel out these A's, because one is in the numerator and one's in the denominator. So it doesn't look like we can cancel anything with this one. So we'd solve that B for B, multiply this side by T over A, and this side by T over A. I'm sorry, not that. Multiply this side by A over XV, A over XV. That cancels out all this, and B is A squared XVT. This one's a little more difficult, but you need to know how to deal with these when you have variables in the denominator, you have squared variables, A squared. The way I would like to write this is meters per second squared, 1 over meters. I'm sort of separating them all. 1 over meters per second, and then 1 over seconds. But then I'm going to go back and rewrite this as seconds over meters. It was 1 over meters per second. So I'd bring that meters per second up into the numerator, and it flips that fraction. And then I cancel. That goes away. That goes away. And I got 1 over second squared meters. Did I do that wrong? Hold on, let me look.
There's 2 A's.
Oh, yes. Thank you. Gosh, look at me. I just missed that question. With practice, you will get it, okay? Like with practice, you'll be better than me. So I'll square this. That means it's going to be meters squared per seconds to the 4th. Let me rewrite this. These meters go away there, that goes away there, and I'm left with 1 over seconds to the 4th.
So why did you switch the velocity?
Because it was in the denominator here, and so it's 1 divided by meters per second.
Oh, okay.
And so that's seconds over meters. Remember we talked about how it's like 1 over a half, that's equal to 2? It's like 1 over a half is the same as 2 over 1. That's why that is. So it will help you a lot if you can deal with fractions. And that's why I like to do this now. I know that you guys are so used to using your calculator, and that's okay. The calculator can be a good tool. But as we go forward in the semester, it will help you a lot to just sort of be able to think about numbers in your head, especially with fractions, as we go through this semester and next semester. I know that's a little scary for some of you, but that's okay. It's going to be all right. I have thousands of students that have done just fine in doing this. Students that are sitting in your place right now saying, can't do this, but you can do it. All righty? All right. You got some knowledge questions about the standards? Let's actually go back down to the other exam, since y'all have that paper in front of you. Scientific notation. On something like this, I don't need to use my calculator at all, because if you use your calculator, you're going to get, this number. I just need to know how many sig figs to report. And so here, I'm doing just multiplication and division, and doing multiplication and division, I don't even worry about the number of decimal places. I just look at the number of sig figs. And so I have 3 here, 4 here, 3 here. So I keep 3 sig figs in the final answer. That's going to be C is the right answer.
And it'll test you like that.
Yeah. I know you might have some addition thrown in there too, and that does make it a little more complicated, but you just, you work through it order by piece. It's not difficult, it just takes a little bit longer. Yeah, absolutely. I'll just make up one. So let's say that actually now let's go back up to that other test. Well, here's one. Yeah, so, but these people got the harder test, didn't they? No, it wasn't really. They're very close in difficulty. So here, 4.1 times 3.45 plus 0.2. The first thing I would do is I'd do the multiplication here. And I don't know what it's going to be exactly, but it's going to be something like 12. Right? I don't know what the number is, 12 point something. 14? Okay, anyway, it's going to be 14. But I don't have any decimal places on that, right? Because I keep 2 sig figs when I do multiplication, the lowest number of sig figs, which is this 4.1. And then I add 0.2. But when I add these numbers, I keep 0 decimal places. So it's just going to be 14. So the answer is going to be 2. Because it was asking not for the result, but how many sig figs should the result have. All right? I think I'll do this in your introductory geomatics classes, right? Geomatics, right?
Yeah. Okay, good.
Are you geomatics too? And women.
Yeah, we're feeling girl in all my classes.
That's okay. No, we've had good women that have graduated from geomatics, so more power to you.
Okay, so we're doing geometry. So it's like, we have a big number, or like one of the I don't know, like there's zeros behind the number.
Oh, wait.
They're not supposed to be significant. Yeah.
Well, you can always express it in scientific notation. That's always your go-to, because when you express things in scientific notation, all the digits are significant. Right, so like if you have 1.25 million, it'll be 1.25 times 10 to the 6. Is that what you're asking?
Mr. Johnson had explained something about like, it looks like a line of one big number.
Yeah, so if you have, say, 12,000, or let's say 120,000, and really you know that number accurately, not to 2 sig figs, but say to 4 sig figs. I don't do this in this class, but this is a good practice, that you would put a line over that. Oh, not that one.
You put the line
Over your last significant figure. And then that tells the person that, hey, I know this value reliably to those 4 significant figures. And those zeros, those 2 zeros are actually significant. That was in that video, that really cheesy sig figs video. He mentioned that. He put a line over the thing. But we don't spend that much time on sig figs in this class.
In chemistry, we did something like that with like just 5,000, but it didn't have decimal places. You're saying how it was like 168.
Right, 5,000 with no decimal places, just the 5 is significant. This is something that I do in this class. Sometimes you'll see this on tests, but it won't really affect your answer that much. So let's say that you have 5,000. That number has 1 significant figure. But if I do this, that number now has how many? 4 significant figures. All right. If I did this, that would have 5 sig figs if I added another 0. So that decimal point, if it has a decimal point, it makes all of those zeros significant. That I know that digit reliably to 4 sig figs, 5 sig figs. Okay. That's probably more than we need to talk about it, but are there more questions? It's just sig figs are going to have 1 question. So there were several questions on the tutor assignment. I think that you'll be okay with after what we talked about. Right? Y'all done those questions? Yeah, working on it. Good. Okay. You're gonna have some trig. You're gonna have unit conversions. Let's do this number 9. We can come back to the trig. This is the one that y'all have in your book? The other one. Okay. $18? Haven't gotten there yet. Oh, we're gonna get to that on Monday. We can begin looking at it. Let's do these though, and then we'll begin looking at it. Let's look at number 9. I want to make sure that you can do unit conversions, because likely on your exam, you're going to have a unit conversion that has a power in it. All right, it's not just going to be like meters per second to miles per hour like we did in class. It'll be one more like this, where I have a power, a variable that's raised to some power. So 12 meters per second squared, and I want to convert it to miles per hour squared. So that's going to be 1 hour is 3,600 seconds. But since the seconds is squared, I have to square that entire conversion factor. And then 1 mile, I'm told, is 1,609 meters. I expect you to know the number of seconds in an hour, seconds in a minute, but I don't expect you to know the British system. And then that's equal to, or whatever, I think it's like, is it 97,000? I'm pretty sure B is the right answer. Is that right? Yeah, 97,000. Okay. Y'all want to do some stuff, preview for next week in our last 10 minutes or so? Just so it'll be, like it won't be new when we do it?
Yes.
This is sort of in your OpenStax homework assignment, which is due. We're going to spend a lot of time talking about graphs of motion. We're going to talk about 2 different graphs of motion. One is going to be position, or x versus t, and then one is going to be velocity versus time. Now, let me show you, if we're doing a velocity versus time graph, and say it looks like that, what this graph means is that initially my object has a big positive velocity, because this is my first quadrant and v is positive, and this is my second quadrant or my fourth quadrant, and v is negative here, right? Number 1, 2, 3, 4. So v is positive, v is negative. So initially v is really big and positive. Positive means that it's in the positive direction. So if it's in the x direction, it's in the positive x, or it's to the left if it's negative. So big and positive right here. What is v at this point? It's 0. So the object is going really fast, it's slowing down, and it stops right here. And then the object begins speeding up, increasing speed, but in the negative direction. Can you think of an object that does that? That decreases in speed, stops, and then increases in speed in the opposite direction, huh?
Swing.
Yeah, swing. It's a little more complicated with a swing, but yeah, that's a good one. A yo-yo, that's a good one too. Yeah, so we'll talk about this. Things that move like this, that you throw up in the air, a basketball, they start with a really big positive velocity right here, and they increase, and then they stop, and then they come back down again. Now when we're looking at graphs, we'll talk about several things. We'll talk about the slope. Y'all know how to find the slope, right? Rise over run. You'll have to do that a lot, finding the slope of a graph. And the slope of a v versus the slope of an x versus t graph is equal to the velocity. You think about the units. X is in meters, t is in seconds, and so the slope of that x versus t graph is meters over seconds, meters per second. That's velocity. The slope of a v versus t graph, what are the units of the slope of a v versus t graph? Yes. Who said that? Yes. What's your name? Michaela. That's right. It's meters per second squared. Because it's meters per second divided by seconds, which is meters per second squared. Okay? So the slope of a v versus t graph has units of meters per second squared, and that's equal to what? All right? So if I find the slope of this graph, which is rise over run, first of all, is that slope going to be positive or negative? It's going to be negative, and it has some value. So this has a negative slope, so it has a negative acceleration. And in fact, we'll see that when we're doing free fall, that an object that's moving in the Earth's gravitational field will always have negative acceleration. This object, even when it's moving up, has a negative acceleration. Oh. That's true. Even though it's moving up, it has a negative acceleration. And even when it's moving down, it also has a negative acceleration. And even when it's stopped at the top, it still has a negative acceleration. Every point in its motion, after it leaves my hand, it has a negative acceleration. Okay? There are a few other details that we're going to fill in next week, but I just started giving you a preview. Now, what if we have a graph that looks like this? Hold on, what am I doing here? An x versus t graph. I want to think about the slope. Now, the slope of this graph gives me what? The slope of an x versus t graph gives me what?
Velocity.
The velocity. And so how is the slope initially? First, is the slope here positive or negative? Positive. How about here? Still positive. It's different though, right? Is it bigger or smaller? Smaller. What about here? 0. Very well. Very good. How about negative? Negative. Look what I just did. What did I just do? How are these two graphs different? They're not different. I mean, they look different, but they're describing the same physical scenario. Big positive velocity, big positive velocity. 0 velocity, 0 velocity. Negative velocity, negative velocity. So these two graphs, and you'll learn to do this, describe the same physical scenario. We'll do that next week. Okay? You can do that, okay?
So the difference is like your y value on the left graph is meters, and your y value on the right graph is velocity. So basically, they're measuring the same thing as meters over second. So it's the same. It's measuring the same thing, just like you got the meters and the seconds split up on the left graph.
Sort of, yeah. No, don't think about it that way. This is position on the y-axis. This is velocity on the x-axis. And both of them, they have time on the x-axis. They're parametric equations. They're graphs that show something that changes with time. This shows how the position changes with time. This shows how the velocity changes with time. No. Actually, let's not think of this as x, but think of it as y. You're sort of right, but let's think of this as y. If the object goes up and comes back down again, that's what this is showing. It's showing it going up, increasing, and then decreasing in position. We're going to do this next week. I just wanted to preview it with you for a few minutes. What else do you want to look at? Any other pressing matters? Yeah, tell me your name again. Madeline.
There was a question in the reading assignment, and I don't remember exactly what it was. It was like asking about accuracy,
Uh-huh.
and it was like, I don't know. I don't remember. I don't know what that thing was.
Send me if you have it. Everybody has slightly different reading assignments, like the questions. But if you ever encounter a question and you're uncertain about it, just take a screenshot of it and send it to me. Okay, Madeline?
It was about like the difference between, it was like a word problem. It was like this coach got a new stopwatch and it was like
Oh, did y'all get that one? What's the answer?
it was like either the answer was no. Yeah, it wasn't a good watch because like the range of accuracy was like out of So I put opposite because I didn't really know like what like stuff qualified as like a big difference.
Oh, you wrote them out? Alright, so the answer, can I read your answer? Is this your answer or the strong option? Oh, the correct answer. The uncertainty is too great to distinguish. Yeah, because his uncertainty. Yeah, because the two sprinters are just 0.03 seconds apart, but the uncertainty in his stopwatch is 0.05 seconds. So he doesn't know their times reliably enough to know their times exactly. Understand? So the uncertainty is too great to distinguish between the sprint.
Okay, I know it was easy, but like I was just like reading over it and over, and I was like, I'm just.
And listen, don't sweat the reading assignments too much. Do them because I think it's helpful for you to see that material elsewhere that's not explained by me but somebody else in a slightly different way. And you will get extra credit for that. Not a whole lot. Like I think that it benefits you in other ways. But the homework assignment, that's important. And while you can ask me questions about the homework assignment, I'm not going to work it for you. But if you come in and I see that you're moving in the right direction, like the work that you're doing is in the right direction, I will certainly push you in the right direction, continue pushing you there. Or if you come in and you're completely lost, I might give you an idea, but I'm certainly not going to work it for you. You can work with your classmates. Find somebody that like looks really smart. That's hard to do because like smart people, they just look like normal people. Usually they're just really hardworking people. You're all smart. But find somebody that you can work well with. Alright? Okay, well I think if there are no other pressing matters, it's Friday afternoon, I can bust on out of here. Don't leave yet. I want to stop this and just meet you again on the way out.